An experiment. So this is my attempt at flipping the lecture, starting by giving you much of the lecture to watch in advance of our meeting on Friday, so that you'll be up to speed, so that you'll be aware of the ideas that we would have talked about in the session, and then we'll be able to spend the time together doing some collaborative practical work. It does kind of depend on you all watching this though, so I hope I've left enough time for you to be able to fit that in. So our theme for today is that of play-based learning, and play, of course, is such an important principle, such an important opportunity, such an important place for learning from early years foundation stage all the way up, I would say. Particularly if you're working in computing, play is such a powerful technique. There's much of what professional programmers do looks an awful lot like play, looks like what we might further up the school call experiment, call exploration. Could I remind you that you ought to have read a couple of pieces of text to follow up on last time's lecture. So there was the chapter 3 of Pappert's Mindstorms, which looks at turtle geometry, which will put our work in session last week into something else, something more of a context. And then there's an article which he wrote about Piaget as part of Time magazine's Century's Greatest Minds. So if you could read both of those, perhaps stop the video now and go and read those, because the Papert on Piaget is directly relevant to some of what we're going to talk about in a little while's time. Here's a 19th century German painting of a thing called a kindergarten, a children's garden, which was an invention of none other than Friedrich Froebel. If you have a look at that, have a look at what's going on there. There's lots and lots of learning happening, isn't there? The children are all engaged in really interesting, meaningful activities. They're playing with one another, they're exploring this lovely, rich environment that's around them. Look at the lovely ducks here. What are the grown-ups doing there? Just allowing the play to happen. So much of these children's learning is happening directly through their play in this lovely, rich environment. Now that's a really powerful metaphor for so much of learning when it comes to working with computers. So the kindergarten, as I say, invented by none other than our own Friedrich Froebel. Froebel's renowned also for coming up with this notion of the Froebel Gifts, which are a series of 12 presents that you give to a child between the age of about 6 months and, say, 3 years, or possibly a little older. Each of those providing a wonderful opportunity for the child to learn through experiments. So if you have a look at the building blocks there, what you have is the child learning about shape, learning about structure, learning about construction through making something with these lovely Froebel blocks. What wonderful toys for the child to play with. I think you'll see some analogy there between the Froebel blocks or these blocks in this Froebel gift and the sort of building block idea that we have when we're programming in Scratch. Very, very powerful technique. It's not just me who spotted that link. The man who kind of invented Scratch, Mitch Resnick, who works at MIT's Media Lab in their, wait for it, lifelong kindergarten group, really inspired by a lot of Froebel's work. Let me show you just a short excerpt from a speech which he gave last January at the Learning Without Frontiers conference. Okay, here we go.
In Paris, and being in Europe for the week, it led me to start thinking about some of the great inventions that have come forth from Europe. And if you start thinking about great European inventions, many people might start by thinking about the 15th century when Gutenberg invented the printing press, and then maybe a few centuries later in the 18th century when James Watt invented the steam engine. These world-transforming inventions. But as I think about great European inventions, it's not these that I think about. For me, the greatest of all inventions came in the 19th century. That was the invention of kindergarten. So, as some of you might know, it was around in the 1830s that Friedrich Froebel invented the first kindergarten. And you might think, well, what's such a big invention about that? Just opening a school for younger kids? But there was a lot more to it than just saying, let's bring younger kids to school. Froebel saw from the beginning that a very different approach to education and learning was needed. At the time, most education was just about a teacher standing in front of the classroom, lecturing, and kids writing down word for word what was being said. And he knew that something very different was needed for 5-year-olds. So he started thinking about a new approach of where children would be actively engaged in designing and creating and experimenting and exploring. And to do this, he recognized that a new set of materials was needed. So he was both an educator and a designer. He started designing what became known as Froebel's Gifts, a collection of materials that kids could use to build patterns and constructions. And he brought these into the kindergarten and supported kids of working on different design activities. And these Froebel Gifts and the ideas of his ideas of kindergarten spread around the world, influencing innovators like Maria Montessori and many others. And we can see in today's kindergarten, you still see some of the echoes of the original Froebel ideas, where children in many kindergartens are actively engaged in designing and creating in collaboration with one another, whether it's building towers with blocks or pictures with finger paint, and working on things they care about and are passionate about. And for me, those are some of the things that make kindergarten a very special place. As kids design and create in kindergarten, they learn many things. When they build a tower with blocks, they learn about stability, what makes things stand up or fall down. When they mix finger paints together, they learn how colors mix together. But maybe most important, they start to learn about the creative process. When I think about the process of learning in kindergarten, I sometimes capture it with this, what I call the creative learning spiral. And it starts with the imagination. So kids might come in and they have an idea of city of the future. And they pull out the blocks and they start creating it. It's not enough just to imagine. You have to start creating. And they start building a tower. And they play and experiment with it. For me, play is a type of experimentation of trying things out. They share it with others. They start working together, and someone will build a house and a road in front of the tower. Maybe the tower will fall down at some point, and they'll start reflecting, why did it fall down? How can I make a better tower? And that gives them new ideas, and they imagine a better building and start again, and it spirals and spirals.
I'm going to pause it there, but it really is worth watching the rest of this talk. It's really quite inspirational, and it fills in some of the background to the Scratch programming language and shows you some examples of what children have done with Scratch. And I think that's going to be important for your learning about Scratch later on in the course. But focus very much now on what Mitch is saying about how important play, experiment, as he makes that link, is to the learning process. So it's no coincidence that his group at MIT Media Lab is called the Lifelong Kindergarten Group. Look at what he's saying here. Inspired by the way children learn in kindergarten, when they create pictures, we want to extend this kindergarten style of learning so that learners of all ages continue to learn through a process of designing, creating, experimenting, and exploring. And isn't that what learning to program a computer, learning to do creative things with a computer is all about? So a world full of creative people who are constantly inventing new opportunities for themselves and their communities. That's a pretty noble ambition, isn't it? Okay, let's backtrack a bit and start thinking a little more around learning theory. You're going to cover lots more of this in the course, particularly in the teaching and learning modules. One of the names you'll come across time and time again is that of Jean Piaget, who was a French biologist originally, and then through observing how his own children learnt, developed this really very deep theory of learning, that learning is, the young child is like the lone scientist, is learning through experience, is learning through experiment. They're trying to establish the rules of the game, the rules of how reality works. They notice that when they do something, the world reacts to them in a certain sort of way, cause and effect, or in computing terms, input, process, output. And how do they go about establishing those rules? He calls that mental model of how the world works, that every child has their schema, plural schemata. And he says that, as you see in the quote there, experience objects plays a really important role in the establishment of those dynamic structures, that as the child's understanding of the world, the schema that they form is based on their experience of concrete objects. They manipulate those objects, and that forms a large part of their understanding of the rules of of the world, the rules of mathematics, the rules of physics, the rules of reality. He says there's two parts to that process, that much of the time this learning happens through this process of assimilation, that we have a mental model of how the world around us works, and new data, new experiences fit into that model and reinforce the connections that are there, reinforce those existing models. Most of the time when you're working with a computer, that's exactly what you experience. I'm sure that we have an idea of how the software works or how the computer works, and most of the time it does exactly what we would expect it to do. This is, I'm sure, what marks out the ICT capable child, that most of the time the computer reacts in exactly the way they were predicted to. But isn't it wonderful once in a while when that doesn't work quite like that? And Piaget describes that as moments of accommodation, that the mental schema the child has, or we have, of how the computer works, changes because of the new experiences, those aha moments when actually our understanding of the real world, where our understanding, in our case perhaps, of a piece of software, changes because it didn't behave how we expected it to. So it's not just a surprise, but it's the opportunity for our mental models to change. Here's one illustration of it. So this is from Atherton's great site about learning and teaching theories. So what have you got going on there? That we have this mental model, and much of the time, through this process of assimilation, new experiences fit into our existing models of reality. It ain't always like that, because there are occasions when the new experiences don't fit into the existing models, and our existing models, our schemata change because of those new experiences, and that's where some really powerful learning takes place. The other thing which Piaget is best known for, I suppose, and this is something which we've kind of moved away from in terms of our understanding of the learning process these days, is this notion of stages of development, that at a very young age the child is in this sensory motor stage, that they can tell the difference between themselves and objects. They recognise that when they do something the world reacts in a certain way, and that objects are still there when the child looks away and comes back later. Later on, they move into this pre-operational stage where they start to use language to think about objects. And of course, Vygotsky talks much more about the importance of language to the learning process, as I'm sure you'll learn later on in the course if you've not already come across those ideas. Still very much taking their own particular viewpoints, still a very egocentric view, and not thinking about all of the multiple dimensions, multiple features of an object. So as you see on the table there. Then as the child moves up through the primary school into the juniors, from the infants, thinking in terms of the concrete operational, aware of the properties of things like number and mass and other physical qualities, and they're starting to hold ideas about how the world works in a much more sort of concrete fashion, as Piaget would describe it, and aware of the different properties of objects, but still very much grounded in a direct experience of those objects. So thus we still work with maths apparatus, because that allows them to start thinking about the properties of number. And then Piaget would see, moving into secondary school, they can start thinking about the ideas without having to have the concrete objects there on which to base them, because perhaps of that familiarity with language, that they're starting to be able to think in a more formal and more abstract sort of sense. As I say, largely, I wouldn't say discredited, but I think most of us have moved away from this notion of there being these fixed stages in a child's development. Nevertheless, you might find it a helpful technique. To move into the slightly more sort of personal experience here, here's my daughter at the age of about 4 months playing with the iPad, and I'm really proud of this. This is her first creative work. This wasn't done with finger paints on a piece of paper. Perhaps an example of poor parenting there, but we sat out in the garden and she started playing with the screen. You see the idea there of the cause and effect, that she does something on the iPad screen, it reacts in a certain way to her touch, and she starts then to develop a model, an understanding of how the computer works. I'm not telling her how an iPad screen works, but through that direct experience of it. She's seeing that when she touches it in a certain way, it reacts in a certain way. And of course, she's gone on to do to play more and more with the sort of technology that geeks like I have lying around our house. So this is her, experimenting with email. So, Sophie, with her first experience of a screen is my wife's iPhone screen. As I say, her first creative work working on my iPad. This is a child who's growing up in a very technologically rich environment. So, the term digital native is one which you will hear, and I think most folk working in the field tend to feel that it's too simplistic a designation, and perhaps even an unhelpful designation. Mark Prensky, writing about children who've grown up in this sort of technologically rich environment, describes them as digital natives and argues that they think differently to how those of us who've become used to technology or digital technology later in life think. It's an argument based, I suppose, on brain plasticity, that those early experiences, the experiences we have, not only change the mental models we have, but actually change the way our brain is structured, and thus change how the child thinks, not merely their model of reality, but also the thinking process. So Prensky says that the digital natives, whatever that may mean, and as I say, a largely discredited terms, behave like this, that they don't want to be lectured to. Compare and contrast, what do you think about that, folks? They want to follow their own interests and passions. They want to make decisions and share control and have a degree of autonomy there. This last one penultimate one is quite interesting. They want to cooperate and compete with each other. I think most of us as educators, certainly at Roehampton, would be very happy about the notion of cooperation, but perhaps a little more worried about children's natural, perhaps, propensity to want to compete with one another. This is something which you might want to return to when we meet on Friday about these ideas. I think it's fair to say, though, that many even of my generation, who could hardly be described as digital natives, although I'm born the same year as the internet, feel this way too. I don't think it's quite as simple as Prensky paints it. This is not something which is peculiar to your generation and those who are younger than you, is it? Again, that's possibly something for us to return to later, so I'm just scrolling down the rest of the slides here. Let's think a little more about play. There's a very good document which I put onto Blogfolio for you about what play means. If you're not familiar with what goes on in early years foundation stage settings, then getting a feel for what play is like would be time very well spent. Particularly those of you who are aiming to teach in Key Stage 1 early years, that's going to be absolutely crucial to your professional practice. But I'd say further up the school too, particularly in the domain of ICT. Look at the words up on the slide there. Play allows children to test their ideas. Play lets children learn from mistakes. Are these not things which would apply generally to good education? Good education allows children to test their ideas. Good education lets children learn from mistakes. Good education fosters imagination and flexibility of mind. Which bit of the school do you not want that sort of thing to be happening in? Rich enabling environments like you saw in my 19th century kindergarten painting. Aren't they something which you'd also want to provide to your Year 6 children? Aren't they something you'd also want provided for you at university, perhaps? And, again, thinking of Prensky and the digital natives here, they want to make decisions and share control. And play an experiment here allows children to dictate pace, length and focus. Interventions should be supportive. Isn't that something where that autonomy, where that degree of children being at the centre of the learning process, is that not really something which we'd want to continue further up the school? And look at this, recognising children's fascination with curiosity about what is going on in their world. Isn't that something which we ought to be maintaining throughout primary and I'd suggest even secondary and tertiary education? My daughter, the age of 21 months, still absolutely fascinated with the world around her. All the new interesting experiences that provides her with. I worry that, at some point during primary education she'll lose that sense of awe and wonder about the world around her. And I think that would be such a loss. I really do. We also distinguish between play in this general sense, which, as I say, is something which I hope we'd want to continue much beyond, beyond the foundation stage, to this notion of free flow play, where the children are much more in control of what's happening. Where if there is that contrast there, and I do hope you'll get the chance to go into an early years foundation stage setting, a nursery reception class, and see this at first hand, and look at the sort of thing that's going on there, using first-hand experiences from life, making up the rules as they play. This is the thing which distinguishes play from games, that the rules of play are things which the children themselves evolve, whereas typically with a game, those are rules which somebody else has set up beforehand, symbolically represent as they play, using their imagination, making things be something other than they actually are. And look at this sort of chimney high sense of flow that happens in free flow play, deeply involved, very difficult to distract. Wouldn't this be lovely to see in more and more primary lessons, that children are coming up with their own symbolic representations, that they are trying out their acquired skills and competences? And whilst we could say that these ideas of play, of exploration, are ones we would continue, I think it's much harder to try and maintain a sort of free flow state of play further up the primary school. You might regret that. Children playing with technology, of course, what's going on here is they're testing their ideas, they're learning from mistakes, it's fostering imagination, and we're providing rich, enabling environments. So how do we do this when it comes to technology? Putting the tech into the hands of the children and allowing them to make up the rules, to pretend, and hope that they will try out their most recently acquired skills. There are some lovely, lovely toys, technological toys, which you see in many early years foundation stage setting. I think the most common that you'll ever encounter are the Bebots, and come Friday's lecture you'll do some practical work around playing with Bebots, or creating a play-based activity around the Bebots. I have a little video to show you again of those in action. That's Mitch. Here we go.
Okay, Jack, this is going to be crazy. Jack, can you make Bebop go all the way around? Wait. Okay.
1, 2, 3, 4, and turn to the left.
Actually,
To the
wait, everybody, shh, don't confuse Jack. Wait, shh. If you want to turn, you need to be quiet.
Where was I at?
You counted to 5. 1,
2,
2.
3, 4, 5.
Okay, good. And then turn to the what? Okay.
And go 1, 2.
Yep, very good.
1, 2. Then turn.
Yep.
Then 1, 2, 3, 4, 5.
Well, let's see if this works.
1, 2, 3, 4, 5.
Okay.
Go, Viva! Go, Viva! Go, Viva! Go, Viva! Go, Viva!
I don't know, is he going to do it?
Go, Viva! Go,
You going to do it, Jack?
go,
Turn! Oh, he's doing it. Jack. Wait. Wait. All right. Okay, Jack, let's sit on the line.
Well, certainly not free flow play, but the ideas of experiment, of trying out ideas, I think we do see there in this activity which the practitioner has set up. The other lovely thing, of course, to see there is how involved all of the children are in this process. They're very much on Jack's side, I think. There are other robots around. Let me show you one of the ones from the old days. This is called a Roma. Some of you, I suspect, may remember this from your own school days, from what was said last week. So we've got this big sort of 30 centimetre across robot, which takes a couple of really quite powerful batteries. There is, I think, a new edition around for this. So we have a couple of these in the Lallam ICT suite if you want to have a play with the old tech here. This is only 30
Go!
I'm sure you get the idea. As I say, there is a newer version of these around, but we're not going to spend time. Oh, and Doctor Who and the Bebots is well worth watching if you want to search for that on YouTube at some point. And then further up the primary school, you can continue to play with the robot toys. The Probots are really quite sophisticated little robots, which understand quite a significant subset of logo programming. And again, we've got a few of those around the LLMIT suite if you want to have a play with those. The music is very loud on this video, so I'll just play a little of this so that you get the playfulness, putting the camera on top of the Probot and seeing sort of Probot's eye view, much as we might have a camera mounted on the dash in an F1 car or some such. Okay, so that's the three robots which you're most likely to see in early years Key Stage 1 and Key Stage 2 settings, to be fair. I have a few questions which it's worth your thinking about, and this is not something which I want to spend time analysing with you now, but I think when we come together on Friday, these might form the basis of an interesting conversation, or you might like to tackle one of these in a follow-up blog post. I'll just leave you with those on screen for a moment to think about those. The other conversation which I'd quite like to have with you is one about how relevant Pappet's logo work is in this day and age. So I think I'm going to stop the recording there and hope that this has been a useful experience for you. What I'd very much like you to do now is to ask one question about the material that you've read and the presentation that I've just given. So post that into the comment space on Blogfolio, and one question from everybody would give us a really good starting point for some useful work when it comes to Friday's lecture. All right, thank you very much for watching.